you just need to figure that out. I think it's next Tuesday. Next week's schedule's all messed up. So let's practice a little bit. We haven't quite finished 4-1, but the quiz will be like these problems on here, okay? Even though this isn't all of 4-1 because we haven't quite finished it. So you guys need to find practice quiz 4.1. Now the actual quiz will not be this long, but it will have problems that come from this sheet, okay? So this is what you need to know, and then the quiz will only have 3 or 4 problems on it.
The questions will come from this sheet, or the
The type of questions will, not the exact questions. Okay, so here we go. Turn this on already? Yep. All right, so how many radians are in 315 degrees? So we're going to remember that we can always change from radians to degrees and vice versa by a little proportion. So pi over 180 equals something over 315, right? That's a surefire way to do it. I'm not saying there aren't other ways to do it, but this will always, always work. And there's no reason to be confused. So x equals 315 pi over 180, and we can reduce the fraction. So let's see, 5 goes into 315, 63, and now 9 goes into both of those. So I got 7 pi over 4 as my answer in reduced form. Okay, that's easy. Easy, easy, easy. Find decimal degrees for 136, 12, 19. So this, remember, we're going to type in on our calculator. This would be purely type in on the calculator. So everybody's going to type in 136 second angle degrees, 12 second angle minutes, and then 19 alpha plus. And hopefully you came out with 136.205. I'll just round it 1,000 since there are directions there. Okay, everybody remembers that? Okay. Find the radius of a circle in which okay, so we got a picture that looks like this. We got a central angle that's 1.4, and it creates an arc that's 38.6, and our job is to find the radius. So this is the picture that would be appropriate to that given information. Not that you have to draw a picture, but that would be the picture. And we know that arc length equals radius times radians. And we know that when an angle measure is given with no mark on it, no degree mark or anything else, it's a radian measure. So this is a radian angle. This is our arc. So we're just going to say 38.6 equals something times 1.4. And then we'll just divide by 1.4. So 38.6 divided by 1.4. And our radius is about 27.571 inches. Yep, because the radius unit matches the arc length. Easy peasy, right? 4 radians are how many degrees? It's that question exactly, only the other way around. This time I need the degree. degree measure. So pi radians is 180 degrees. 4 radians is how many degrees? I can use exactly the same proportion, changing from degrees to radians or radians to degrees. So pi x equals 720, and x equals 720 over pi degrees. That's the degree measure for 4 radians. Find the navigational angle for west-northwest. Okay, so you gotta remember what our compass looks like. Here's my compass. Here's north and west. I'll just stay over there since that's what the problem is about. I know that if I split the difference, this would be northwest. And then I want to be west-northwest. So I want to be on the west side of northwest. So on the west side of northwest. Everybody okay with that? Now remember, when you measure, you're starting at due north going clockwise when you're doing angles. I mean, navigational angles. So I'm going to start up here. This is 0. This would be 90, 180. Here's 270. So I got to go all the way around to 270, and then I got to go this much more. Now, remember, a quadrant is 90. So the black line would be 45. And splitting that would be 22 and a half. So I have to go 270 and another 22 and a half. So what is that? 292.5 degrees is our navigational heading for west-northwest. Okay, draw an angle of negative 190 in standard position. Okay, this is not standard position, that's navigation. If we're drawing an angle in standard position, we're using our coordinate axis system, and we're starting here. That's where we're starting. And we're going negative 190. So negative means down, clockwise is negative, and I need to go 190. So that would be all the way around to here and a little bit more. So this angle would be negative 190 degrees. Your ability to draw angles correctly is going to be huge in the next section and the rest of the chapter. Okay? Really forever in your life in trigonometry. Find degrees, minutes, and seconds for 78.136. Remember how to do this? We go back to our calculator. 78.136. And then second angle and choose DMS. So it's 78 degrees, 8 minutes, and 9.6 seconds. And then, just to make sure we don't forget, I snuck a little logarithm problem on there. That's a potential quiz question. So we got to remember, how do we solve logarithmic equations? Oh, Miss Ford, can't we just forget this? No, because you can mix logarithms and trigonometry, believe it or not, so we have to remember what the rules are. So, 2 log 5 x minus 8 plus 4 equals 10. How do you think you'll start? Minus 4, absolutely. So 2 log 5, base 5, x minus 8 equals 6. Divide by 2, always, yeah, we gotta get rid of that coefficient. Loop-de-loo. So 5 to the 3rd equals x minus 8. 5 times 5 times 5 is 125. Equals x minus 8. So what is that, 130? 33? Okay, so let's put that away. You might want to get that out sometime between now and Tuesday and look at it. I mean, it's easy stuff, but it's a long time between now and Tuesday. All right. So now we're going back to our notes. We're going to finish up this section today, meaning that your homework for 4.1 will be due Tuesday also. Okay, Tuesday, I think that's a day 1. So we'll have office hours. If you are struggling with some homework problems, you can come in and we can work on them. Not the whole sheet though, not the whole sheet. Come in with your questions. All right, automobile design. Table 4.1 shows size specifications for the tires. Okay. Find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute. Okay, I am not going to do all 3 of them. I am just going to pick one because they'll be done exactly the same way. So if you want to do the extras for practice, you certainly can. So I'm going to pick the, I guess the Ford Taurus because my name's Ford. So I'll pick that one. And I'm going to find the speed of that vehicle when the wheels are turning at 800 revolutions per minute. Now, I am going to start with the idea of I have 800 revolutions per minute. And I know that I eventually have to end up with miles per hour. So I'm going to do a whole bunch of stuff here, but I'm eventually going to end up with miles per hour. Okay, that's what's happening in the problem. Now, I have a wheel that has a diameter of 26.16 inches, which means its radius is 13.08 inches. Is that right? So every time that wheel goes around, think about it, if that wheel goes around, doesn't it travel a circumference? Isn't a revolution of the wheel the same as a circumference? So I'm going to say, okay, that's going to be 2 pi, well, what's 2, oh, that's the diameter, so 26.16 pi inches per revolution. This wheel travels 26.16 pi inches per revolution. Would you agree? Now, I don't want inches, I need miles. Okay? So I am going to say 1 foot is 12 inches and 1 mile is 5,280 feet. You see what I'm doing here? What's happening to my units? They're canceling. Yeah, you've done this before. You do it in chemistry all the time. Now I have miles exactly where I want them, on the top. But I'm supposed to have hours, and I've got minutes. So I'm going to say there are 60 minutes in 1 hour. And when I start canceling, there go my revolutions, there go my inches, there go my feet, and here go my minutes. And I am left with miles per hour. So all I need to do now is multiply everything on the top and everything on the bottom, and that will give me my speed. So 800 times 26.16 pi, and go ahead and use your pi button, times 60. That's my numerator. Did I get it all? Yep. Now, if you're going to just put in, if you're just going to hit divided by, make sure you put parentheses because you're actually going to be dividing by two numbers, right? 12 times 5,280. So my speed is 62.26 miles per hour. Now, when I said I wasn't going to do all three of these problems, think about it for a second. What is the only thing that's going to change in this? This right here, right? Nothing else is going to change because aren't they going 800 revolutions per minute? Yeah. And all of this is standard. So the only thing that's going to change is that number right there. So if you want to do the others, go ahead, but that's the only thing that'll change. So I can't do the second part because I haven't done the others. All right, one more. Bicycle racing. Kathy races on a bicycle with 13-inch radius wheels. So now we got a wheel with 13-inch radius. She's traveling at a speed of 44 feet per second. So I'm going to do the same sort of thing, but this time I'm beginning with 44 feet per second. That's what I'm starting with. And I want to end up with how many revolutions per minute. So this time I am ending up with revolutions per minute. Well, the first thing you probably notice is you got seconds and you need minutes, so that's easy. We'll say there are 60 seconds in 1 minute. And then we have our minutes on the bottom and we're done with that. But this is now, it's not tricky, but you have to think about it for a second. We've got a distance and we need to get it in terms of a revolution. Now remember, a revolution is a circumference, right? So one revolution will be a circumference. Well, what is the circumference of this wheel? 26 pi inches. Now, you might think, oh, great, I have revolutions on top and minutes on the bottom, but wait, not everything's canceled, has it? So now we got to make sure these inches and feet cancel, but that's easy because 12 inches makes 1 foot. And now everything's gone. The feet are gone, the seconds are gone, the inches are gone, and all we have left is revolutions per minute. So 44 times 60 times 12 divided by, be very careful, there's only one fraction there, but it's two things. So parentheses, 26 pi. And did you get 387.848 revolutions per minute? All right, everybody okay with that? All right. All right, let's get out our yellow sheets. We're going to need it today because we're going to start actually doing some trigonometry. So I just want to go through the yellow sheet and make sure that you understand what it is you're supposed to be memorizing. It's important to note that the yellow sheet is not something you're going to be using on tests. This is stuff you just need to know. So, there are 6 trigonometric functions, what we call trigonometric functions. Sine, cosine, tangent, cosecant, secant, and cotangent. I have very strategically placed them on the paper the way I did because I put them next to their reciprocals. So sine and cosecant are reciprocals of each other. So if I tell you the sine is 1/4, you are immediately going to tell me the cosecant is 4/1. They're reciprocals. Secant and cosine, and tangent and cotangent. Kids have told me in the past, it's been so long since I memorized these, I don't even remember how I did it. The kids have said they keep it straight because each pair has only one co. So it's sine, cosecant, that's a pair. Cosine, secant is a pair, and tan, cotan is a pair. So if that helps you keep straight what's with what, each reciprocal pair has one cofunction, okay? All right, now, when you learned about trigonometry back in geometry, I'm sure you did it with reference to the chief of the trigonometry tribe, Chief SOHCAHTOA. Because that is absolutely an awesome mnemonic device to help you remember what's what. The big three functions, the ones on your calculator, are sine, cosine, and tangent. They are defined in terms of right triangle trigonometry. So let's back up. We will spend a ton of time in chapter 5 with non-right triangles. All of this stuff that we're talking about today is right triangle trigonometry. Because what does the H stand for? Hypotenuse. So this is opposite over hypotenuse, and if this is our angle, I'll call this angle theta. If that's our angle, then this is the opposite side, this is the hypotenuse, and this is the adjacent side. Wherever your angle is located, the side across from it is opposite. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now remember, the other three, cosecant, secant, cotangent, are just the reciprocals of these. So if you can remember SOHCAHTOA, then you can do all 6 functions. Cosecant, hypotenuse over opposite, secant, hypotenuse over adjacent, and cotangent, adjacent over opposite. The functions are also defined. This is right triangle definition, opposite, adjacent, hypotenuse. The same functions are defined with what are called the circular definitions. And yes, you need to know them too, and you will find out why very shortly. If we put our triangle in here, obviously this is the radius of the circle. And if I were going to plot this point, this side would be the x amount, and this side would be the y amount, right? So if I look at that triangle, the opposite side is y, and the hypotenuse is r. So the sine is y over r. Opposite over hypotenuse, y over r. I've also included the abbreviations there, just so you remember that the word SIN in Mathland stands for sine, S-I-N-E. Don't say sin, makes you sound a little goofy. It's sin x. Cosine is COS, so cosecant is CSC. Needed a different abbreviation. The rest of them are pretty standard. And then, back when you were in geometry, you learned all about your special right triangles. 30, 60, 90, 45, 45, 90. We have to know them. Because you are going to have to find the sine of 45 degrees without a calculator. And that is so easy if you remember the sides of your triangle. So I put them on the sheet too, in case you had forgotten. All right. So, and then on the back of the sheet are the graphs. We're not going to use those for a little bit, but you're going to need to know those two, the graphs of the functions. Sine and cosine are part of our BFF list, so you're kind of familiar with those already, but now we're going to add labels that we didn't have before. But yeah. Okay, so let's look at what we're doing now. We've got our sheet, we're all ready to go. Let's look at our problems. Find the values of all 6 trig functions of theta. Remember, theta is your variable, nothing to be scared of. It's a Greek letter, stands for the angle. And this particular triangle is situated like this, which means this is the opposite side, and sometimes it helps to label it, especially when you're just getting started. This is the hypotenuse. Uh-oh. I don't know it. Can I figure it out? Yes, using the Pythagorean theorem, right? These are right triangles, so you're always going to have access to the Pythagorean theorem. All right, so here we go. I don't know what this is, so I'll call it x. So x squared plus 4 equals 25. So x squared equals 21. And this side is the square root of 21. Would you agree with that? So now I know all 3 sides, so finding my functions is easy. Let's do these first, and then we'll just flip them over and get these. All right, here we go. What's a sine of theta? SOHCAHTOA, opposite over hypotenuse, so it will be 2/5. Easy. What about the cosine? Yep. Don't act bored, this is exciting. And the tangent? Tangent is opposite over adjacent, so it'll be 2 over root 21, which you can rationalize. You remember how to do that, multiply top and bottom by the radical.
You have to do that?
Yep. I'll be honest with you, there probably will come a time in your math career when they don't care if you do that or not. So in high school we still care. All right, now these are the reciprocals. So if the sine is 2 over 5, then the cosecant is just going to be 5 over 2. If the cosine is root 21 over 5, the secant is going to be 5 over root 21, which I'll rationalize. And now with the cotangent, little hint, flip this version of it. It's easier to flip that version of it, because if you flip this one, you're going to have to rationalize again. But if you flip this one, you're all good. Done. Easy. Okay, let's look at B. I bet you can do this on your own. In question B, we're missing the hypotenuse, right? So you're going to have to figure that out. Which side is opposite? 3 or 5? 3. Opposite is the one that's across from the angle, not touching it. It's the side that doesn't touch the angle, okay? So your opposite side's 3, your adjacent side's 5, and you're going to figure out the hypotenuse. All right, go. And then tell me what your answers are, and we'll see if I agree or not. Okay, anybody have some answers you're willing to share? Reed, what do you got?
For the first one, I got 1/8. Oh, I must have added some more.
Yes. Sine, remember, don't forget SOHCAHTOA. Okay, so sine is going to be the opposite side over the hypotenuse. So that would be 3 over root 30. Oh, did you say 24 maybe?
Yeah.
Oh, okay. No, 25 and 9 has to be bigger than 25. Yeah, so it's 3 over root 34. So that's going to be 3 root 34 over 34. Our cosecant is root 34 over 3. All right, who got a cosine? What's a cosine? Read, you want to try again? What's cosine? SOHCAHTOA.
I'm sure what you're looking at. I'll be back with you.
Okay, can you just look at my picture and tell me?
Sure.
Adjacent?
That would be 5 over square root 3.
Yep. Which will rationalize and get 5 root 34 over 34. And my secant is root 34 over 5. Tangent's the easy one in this one. Danica, what's your tangent? 3 over 5, which makes the cotangent 5 over 3. Michael, look alive. Yes.
How do we get square root of 34 again?
Pythagorean theorem, 9 plus 25, a squared plus b squared equals c squared.
Okay.
All right, now, the next problem is a little bit different because they didn't tell you really anything about the triangle, although I drew a nice little picture there for you so you would know how to set it up. All they told me is that the secant is 3 halves. So on the basis of that, I'm supposed to find all of the rest of them. Well, one of them's easy, right? If the secant's 3 halves, then cosine's 2/3, yeah. And remember, SOHCAHTOA, this is adjacent over hypotenuse. So I can come back to my picture. Your angle's here. So this is adjacent and this is hypotenuse. Remember, the side that doesn't touch the angle is opposite. So adjacent over hypotenuse looks like that. And then I'm sort of back to where I was a minute ago. I can find my third side. What will my third side be using the Pythagorean theorem? Yes, very good. Remember when you do the Pythagorean theorem, the hypotenuse is the side that's over here by itself. You don't just automatically add those two. That's not how it works. The legs add up to the hypotenuse, the square of the legs. So root 5 is perfect. Well, now it's easy. What's my sign? Yep, which means my cosecant is 3 over root 5, or 3 root 5 over 5. And then my tangent, root 5 over 2, and the cotangent 2 over root 5, or 2 root 5 over 5.
I don't know. I think there's still one.
So easy? All right, try the next one. Use the same picture. I didn't draw it for you, but go ahead. This is the way we set these up. So use that same style of picture for problem 2B. And this time we know the tangent value is 4/5. And you're going to find all the rest of them based on that. So I'm going to go ahead and squeeze in the cotan because that's obvious. before you get too far, does everybody have the 4 and the 5 in the right spot? What did you put here? 5. What did you put here? 4. And this is the one you need to use the Pythagorean theorem to find? And hopefully you got root 41? Okay. So now go ahead and fill them in. Tell me what you got. Hector, you got them?
I think so.
All right, would you just give me your final answers? What'd you end up with sign?
5 root 41 over 41. Is that right?
Did you say 5?
4.
4, yeah. 4 root 41 over 41. Yep, that's perfect. So this one, what did you get for cosecant?
4 or root 41 over 4.
Perfect. Beautiful. Okay, how about cosine?
5 root 41 over 41.
Yep. And then secant would have been root 41 over 5. Everybody okay with that? Easy. Okay. Find the exact value, no calculator. Okay. Without our calculator, we're going to find the value of the sine of pi over 3. Now, most of you hadn't even seen a radian measure until, a couple days ago. Maybe it was yesterday, I don't even remember. You might want to convert this to degrees. Might be easier for you. So let's try this again. This didn't go over so well when I did this the other day. Let's try it again. We know that pi is 180, right? So what would pi over 3 be? If a whole pi is 180, what's a third of a pi? 60. Yeah. This is 60. Remember, pi is 180. We're dividing that by 3. So this is 60 degrees. Now, if you want to set up your proportion, pi over 180 equals pi over 3 over x, perfectly fine. But you're going to be doing a lot of these, and it's going to be quicker if you kind of get this idea that a whole pi is 180. So a third of a pi would be 60, a third of 180. So now I'm going to draw exactly the same picture I was using before, because this is a 60-degree angle in standard position. And that's how we're going to draw our angles in standard position. Now, obviously, this is a 30, 60, 90 triangle, right? The important angle is always the one at the origin, the one vertexed at the origin. That's your 60. In a 30, 60, 90 triangle, I know the sides are in that special relationship that's on your memorization sheet. I know that the side across from the 30 is always 1. So whatever side is across from the 30, it's 1. The hypotenuse is 2, and the other side is root 3. That will never change, no matter what. They're always in that ratio. Now, I want to know the sine of this angle. Well, sine, so katoa, sine is opposite over hypotenuse. So in this triangle, there's your angle, always at the origin. Which side is opposite? Square root of 3. And hypotenuse, of course, is 2. So the exact sine of 60 is root 3 over 2. Now, this is something that you want to remember how to do. You know how teachers have to have meetings on, I shouldn't say have to, you get to have meetings on, what is it, days 2 and 4? Well, my PLC group, of course, is with the pre-cal teachers, but Mr. Shadio, the AP calculus teacher, is also in there. And we always say to him, okay, what do these kids need to know? What are we missing? What do we need to emphasize? And we just talked about it, not today, but our last meeting. They need to know this. And you need to know it like this because it's going to come up in so many different problems that you do in your calculus class. So I'm not just going through the motions here, kids. This is important stuff. You need to get it so that you can remember it. All right, let's try secant pi over 4.
This is Ford. Real
Yes.
quickly, Jacob Blow is trying to get into the Zoom.
Oh, thank you.
You're welcome.
He's only a little late. Okay, so here we go. First thing, we memorized our triangles in 30, 60, 90, not pi over 6, pi over 3, pi over 2. So let's change this to to degrees. So a pi is 180. What would a fourth of that be? What's a fourth of 180? 45. So this is the secant of 45 degrees. So I'm going to draw my 45 degree angle in standard position. Right there it is. It's a right triangle. So 45, 45, 90. And I know that the sides of a 45, 45, 90 are always 1, 1, root 2. They're in that ratio, I should say. They're in that ratio. 1, 1, root 2. So the legs are 1. They match because the angles match, right? And then the hypotenuse is root 2. So based on that, what is my secant? Root 2 over 1. Very, very good. And we're just going to write that root 2, but it's root 2 over 1. Now, SOHCAHTOA. We know that cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. Hypotenuse over adjacent. Kids, there's a lot to remember. You got to know secant's reciprocal of cosine, and you got to know cosine is adjacent over hypotenuse. And you got to know the sides of a 45, 45, 90. See, there's just so much to know. But if you know it all, it's easy. So use the weekend to really get comfortable with that yellow sheet. All right, tangent pi over 6. Tangent pi over 6. How many degrees is that? 30? Beautiful. 180 divided by 6, a sixth of 180. So I'm going to draw the same picture I've been drawing. 30 degree angle. Drop a perpendicular, so I have a right triangle. Across from the 30 is always 1. So the triangle may be situated differently, but across from the 30 is 1. The hypotenuse is 2, and the other side is root 3. So tell me about the tangent. What's the tangent? Well, SOHCAHTOA, so it's opposite over adjacent. So hopefully you put 1 over root 3 and then rationalize it to get root 3 over 3. Now, if you type that in, if you type tan 30 in your calculator, it will not give you this. It will give you some decimal. But remember, the directions said exact. And anytime the directions say exact, Now I went ahead and put no calculator as a reminder there, but anytime it says exact, that means exact. No rounding off, no decimals. Doing it by hand. All right, do the last one on your own. Cosine pi over 3. Tell me what the cosine of pi over 3 is. Raise your hand when you get an answer. It'll be a fraction. They're all fractions, kids, because they're all something over something. Hypotenuse over adjacent, or opposite over hypotenuse, something like that. So I have 2 hands up. There's a few more. How many degrees, Josh? Pi over 3?
Cosine 60.
Cosine 60. So we got our little 60-degree triangle here. We know across from the 30 is 1, and the hypotenuse is 2. So Josh, what did you say your answer was?
Square root of 2. Oh, 1 over 2.
1 over 2. Cosine would be 1/2. Yeah, the cosine would be 1/2 because cosine is adjacent over hypotenuse. So the cosine is 1/2. All right, let's get our calculators out and let's practice doing this on our calculator now. By the way, am I going to be able to just randomly make up angles and say, okay, find the sine of this angle or the tangent of this angle? Am I just going to be able to use random angles? No, they have to be some version of 30, 60, or 45, right? Yeah. We're gonna take it a couple steps farther soon, but right now that's enough. Let's look at our calculators now. And I'd like you quickly just to put a little circle around all the problems that are degrees. Every problem that's a degree, put a circle around. Because we're going to do those first. Because remember, you have to adjust your calculator to be either in degrees or radians, and I don't want to have to be switching back and forth. So I'm going to do all the degree problems first, which are which ones, Ellie? What are the degree problems? A, B, and E. All right, so we're going to do those first, A, B, and E. Here we go. Oh, crap. The very first one says secant. Do I have a secant button on my calculator? Shoot, I paid all this money for this calculator, and it doesn't even have the button I need. Any ideas how we put secant in our calculator? There's only one way to do it. That's the trap. The only way to put a secant into your calculator is to remember its definition. What is the secant? Reciprocal of cosine. So the secant of 10 is going to be 1 divided by cosine 10. Do not use this button. That means an angle. That means an entirely different thing, and we'll talk about that. But that is not the button you use. I know you would think so because it looks like a little negative exponent, but it's not. It's the inverse notation. So that's not what you do. You have to type 1 divided by cosine. So I'm going to make sure I'm in degrees. I am. So 1 divided by cosine 10, 10,000. So that one is 1.0154. Now we're doing B. Well, we have a tangent button, so all is good. I'll hit tangent. But then remember, I have to do 28 second angle degrees and 11 second angle minutes. Did you get 0.5358 for B? Anybody not get 0.5358 for B? Oscar, where's your calculator?
Oh, down.
And you send it at home, does it? Oscar, what happens if you forget your headgear for wrestling? You have to sit on the bench, right?
Yeah.
Math is no different. Let's be prepared. Let's be prepared. Okay, now E. Same thing, only this one's got degrees, minutes, and seconds in it. So sine 129 second angle degrees, 18 second angle minutes, and then 13 alpha plus. I got 0.7738. Now, the way when I put these into my calculator in radians, I do everything exactly the same. But I have to change my calculator to radians. So to do problems C, D, and F, I'm going to change my calculator to radians. So I go to Mode, highlight radians, hit enter, and I'm ready to go. C. How am I going to do a cosecant on my calculator? Don't get wild and wacky. What's the definition of cosecant? Reciprocal of sine. So I'm going to type in 1 over the sine of 5 pi over 16. I'm not flipping that fraction. That is the angle. I don't want the reciprocal of the angle. I want the reciprocal of the sine. So I simply type 1 divided by sine 5 pi divided by 16. And you should get 1.2027 for that one. D, nothing tricky there. Cosine pi over 9. Cosine pi divided by 9. Did you get 0.9397? And then we got cotangent 2. How do I know that's a radian measure? No degree mark. That's right, no degree mark. So I know I'm in radians, which is where I need to be, but I need a cotangent. How do I type a cotangent into my calculator? 1 over tan 2. That's exactly right. 1 over tangent. 1 divided by tangent 2. Negative 0.4577. The trigonometric functions are negative half the time. Because when we start drawing our angles in all the quadrants, each function has 2 positive quadrants and 2 negative quadrants. So it's perfectly normal to come out with a negative trigonometric function value. Okay, well, are we awesome or what?